question 7, we have a particle of mass m held at this point here at P on the surface of a smooth sphere, center O and radius R, as we can see in the diagram. OP makes an angle A, so let's have a look at that straight away. OP makes this angle A. So we can get this height here in terms of the radius. The height that it would be above O is going to be, or cos alpha, it's adjacent. We can do the same for Q. We have this right angle triangle, and the big angle is B. Just be careful, it's not the small one, it's the big one. So similarly for Q, Q has an angle B on the same radius, so this is going to be its height above O, which is what we're going to need here, is going to be R cos beta. So we're looking at conservation here. It's leaving B and ending up at Q. So MGH in position 1 and position 2. MGH plus a half mg squared, mv squared for my potential and kinetic energies. So m by g by height, which is R cos alpha, plus a half m by its speed, which is released from rest, which is 0. So we just have mg R cos alpha for the energy here in position 1. Okay, let's look at position 2. At Q here. What happens at Q? We're told we're just asked the arbitrary speed V. So we're looking for the V in this part of the energy system at point 2. So we have mg times R cos beta plus a half mv squared is the energy of position 2. So this would have to be equal to my position 1. So if we multiply that by 2, we're going to get, and divide by m, we're going to get v squared is equal to this guy multiplied by 2g R cos alpha, and we'd have to bring this guy across to the other side, minus 2g R cos beta. What have they done? They factored out the 2g R, so v squared is equal to 2g R by cos A minus cos B for the arbitrary speed at this point. Then we're told if cos alpha is 2/3, and if Q is the point at which the particle leaves the surface, find the value of B. So at the point Q, we have mg towards the center. This will be B with alternate angles. So we're going to have mg cos beta, and then my right angle will be here, making mg the diagonal. We'd have mg sine beta. We'd have the reaction opposing, which is going to be equal to 0 if it leaves. So we'd have mg cos beta minus R, the forces towards the center, are mv squared over R. We're dealing with, which speed are we dealing? We have R mv squared over R, we have v. So with R equal to 0, and if we divide by m and multiply by R, we'll get Rg cos beta is equal to v squared. Let's find the value of B, which we have now in this equation. We have another v squared up here. So if we equate the two of these, we're going to get Rg cos beta is equal to 2g R times cos A minus cos B. Dividing by, I suppose we divide by g R maybe to begin. Divide by or what are we going to have? We're going to have cos beta is equal to 2 cos alpha minus 2 cos beta. So we're going to have 3 cos beta is equal to 2 cos alpha, which we're given the value of 2 times 2 over 3. So 3 cos beta is equal to 4 over 3. So cos beta is equal to 4 over 9. There we go. So beta, the inverse cos of this, is giving me 64 degrees to the nearest degree.